Welcome to Methodical Math. The goal of this video is to go over iterated integrals as simply as possible in a methodical way. This is actually the knowledge needed to solve the surface area of a scalar function, which is a video I made earlier. So let's begin. Let's solve this double integral. It is very easy, so this video shouldn't be really long. So let's start off with our dy over here. This means the first thing we're going to be doing is integrating this by our dy. So of course, let's get into the steps. This in dy is going to be, let me just split it into two integrals. One from 0 to 1, and then we'll go to this one, since you can just simply do that and integrate it through our y's. In this case, it is going to be 6x to the power 3, since this is all multiplication, multiplied by the integral of y, which is going to be y to the power 3 divided by 3. Let's bring up an integral cheat sheet so you can follow step by step how I solve these tiny little integrals. So now that we are given this, let's not write the plus c, which we would usually write. Instead, write it in the range of 0 to 1. The way you solve it next is just substitute the 1 under the y, since we integrated by y's. So it's 3x to the power 3 multiplied by 1 to the power 3 divided by 3. We substituted this 1 into our formula. The next step is to write down the same formula, but this time substituting zeros for y's. In this case, 6x to the power 3 multiplied by 0 to the power 3 over 3. Well, since this is all multiplied by 0 to a certain power, we can just completely skip that part and leave it as 6x to the power 3 times 1 over 3. Since 1 over 3 is just going to be 1, which is equal to 2x to the power 3. Now that we have that out of the way, let's move on to the second integral. Since there are two integrals, you just do them one after the other. We have 2x to the power 3 dx. And we do it the same way. So we integrate the x in the boundaries of the integral, which is 2x to the power 4 divided by 4 to 1. And now we substitute these numbers. The number above we write down first. 2 times 2 to the power 4 divided by 4 minus 2 times 1 to the power 4 divided by 4. And now we simply solve it. So it's simply 8 minus 1 over 2, which is 6.5. There is also an alternative way of solving the same thing, now that you understand the first one, which is simply to pull out the constant before the integral. In this case, since we are integrating by y first, the 6x to the power 3 is going to be our constant, so we can pull it before the integral. As such. And now we're left with y to the power 2 dy dx. And we solve it the same way. So now we are given the integral of 1 6x to the power 3 multiplied by 1 over 3. The solution to this, you substitute y for 1 minus the substitution of 0 for y. which is going to result in the same thing we had in the previous exercise. Alternatively, while looking through some exercises you have found yourself, you can sometimes find integrals, definite integrals with cosines, sines, pi, but you essentially solve them the same way. First, let's rewrite the integral. And now we have sine x plus y. First, we integrate by y, then we integrate by x. Just as in the previous exercise, we solve it the same way for trigonometric functions. So I have added some extra formulas which are going to be needed to solve it. I'm sorry that they weren't in the original cheat sheet, but I also find it pretty frustrating that whenever you Google integral formulas, they never give you all comprehensive list of trigonometric formulas. Instead, you just have to find the more specific ones yourself. But I digress. So the integral of our sine function by dy is going to be minus cosine of x plus y, with the limits of 0 to pi dx. So firstly, let's pull out the minus from the integral, since minus 1 is a constant. And we can do that by, this is a general rule that we can pull out constants out of the integrals whenever they're multiplying something. In this case, this whole expression is multiplied by minus 1. And let's now substitute the pi and 0 to our y. We're given cosine of x plus pi minus cosine of x, just x. I'm not going to write the 0, dx. And now let's use the formula for cosine plus pi. We're going to be given negative cosine of x minus cosine of x dx, meaning minus 2, which we can also pull out, cosine of x dx. Now we just need to integrate the cosine, which is going to give us sine of x in the limits of the integral, meaning pi and 0, which is 2 times sine of pi minus sine of 0, which is going to be 2 times 0 minus 0, meaning 0, since we can just read these values from the trigonometric table of values, which I assume you just know by heart. Thank you for watching this quick little video. If you have any suggestions for future videos, just feel free to write it in the comments. I also teach mathematics. I do private tutoring, so if you're interested, feel free to message me. I've actually helped a few people pass mathematics already. So if you would like to learn more advanced stuff with me, just write it in the comments.